morning, guys. Throwing you a curveball here. This is Mrs. Schmalder, and I'm going to teach you about proportions in triangles today. Our goal here is to learn to use proportionality in triangles and among parallel lines to solve problems. So please take a pause right here and write your essential question. All right, we're going to start off with some theorems. Of course, we love our theorems. First one is the triangle proportionality theorem, and it says, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so let's look at our picture here. A line parallel to one side of a triangle. So here's our line that's parallel to this side of the triangle. TQ is the line that's parallel to the side of the triangle QS. And we can see that it intersects the other two sides of the triangle. Then what we know because of this theorem is that it divides these two sides proportionally. So in other words, what we have here in a proportion is that RT is to TQ as RU is to US. Right? That's what that theorem there tells you. So my question to you is, are these two triangles similar? Well, can we figure that out? Think of all the ways that we have learned to decide whether or not triangles are similar. We've got side-side-side similarity, we've got side-angle-side, and we've got angle-angle. So could we use one of those to show that these two triangles are similar? I believe we could, right? They both share this angle, this small triangle and the large triangle. They both share this angle. And what do we know about these two angles? We know that they are congruent because why? Because they're corresponding angles that are created by these two parallel lines, and this transversal. So yes, these two triangles are similar, and if I wanted to write a similarity statement, I could say that triangle RTQ is similar to triangle RQS by the angle. All right, theorem number 2. The converse of this theorem, and of course you remember, we use the converse of some of our congruence theorems. If we wanted to show that lines are parallel, we would use the converse of the theorem to do that. So that's what we have going on here. The converse of the theorem says if the line divides two sides of a triangle proportionally, then it is parallel to the third side. So what this is saying here is if I know that proportionality is true, so if I know that RT over TQ equals RU over US, then, because of this theorem, I can say that TU is parallel to QS. Right, good theorem there. Next theorem, transversal proportionality theorem. If three parallel lines intersect two transversals, then they divide the transversals just what? Proportionally. Alright, so let's see what we got here in our picture. Three parallel lines, and I can see these are parallel because they're marked. So line R is parallel to S, it's parallel to T. So if this is true, then I know that the transversals L and M are divided proportionally. So what this tells me is that UW, sorry, I don't need that there, talking about lengths, scratch that out of your notes. UW is to WY as VX is to XT. That's what that theorem right there says to you. Alright, last theorem for the day, and then we're going to do some example problems to see how we can use these. The triangle angle bisector proportionality theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional. I told you this lesson was about proportionality. Proportional to the lengths of the other two sides. So, to use this theorem, of course, we've got to know that we have an angle bisector, which we do here because of the congruence markings on our angle. So CB here is our angle bisector. And since we know that it bisects this angle, ACB, we know that it divides this side, AB, into parts that are proportional to the other two sides of the triangle. So what I have here is that AD is to BD as AC is to BC. Alright, and could I write this proportion another way? Of course I could, because you remember some of the rules, some of the properties of ratio says that I can switch my means and extremes. So I could write it this way. I could say that BC is to BD as AC is to AD. Just remember, as long as your cross product comes out the same, you know you still got a good proportion. So this would say BC times AD equals BD times AC. And this one over here would say that AD times BC equals BD times AC. So both of those are good proportions. All right, let's do some practice problems. Here we go. So what is the length of NR? So I'm going to call NRX. That's what we're looking for. And this looks like, I know I've got this side, this segment here that's parallel to this side of the triangle. This NP is parallel to RQ because it is marked that way. So I know I'm going to use my first theorem that I learned a minute ago that said this segment here divides the two sides of the triangle proportionally. So what I know then is that 9 over x equals 6 over 4. And now I'm just going to take the cross product. 6x equals 36. So that tells me that NR equals 6. Okay? Alright, how about another one? This problem here says, given the diagram, determine whether MN is parallel to PQ. So is MN parallel to PQ? So this looks like to me we're going to have to use what? The converse of the theorem we just used. So how are we going to do that? Well, we're going to see if our two proportions, if this divided by this equals this over this, then we know that those two segments are parallel. I have to erase that so I can see my numbers. Alright, so if 42 over 54 equals 36 over 48, then I know that MN is parallel to PQ. So let's simplify that and see if it does. See if those two things are equal. I've got to simplify both of these. Let's see, what goes into both of these? 6? 6 will go into 6 will go into 42 7 times. 6 into 54 is 9. 6 goes into 36 6 times. 6 goes into 46 8 times. I could further simplify this. 2 goes into both of these 3. That 4. And those two things, 7 ninths. 7 ninths does not equal 3/4. Therefore, MN is not parallel to PQ. Alright, how about this one? What is the length? What is the length of GH? Okay, well, we're going to use our theorem that says if three parallel lines intersect two transversals, then those lines divide the transversals proportionally. So, I got a problem. I don't know that FJ is parallel to GK is parallel to HL, or do I? Do I know that those are parallel? Yes, I do. Why do I know? Because I can see that the corresponding angles are congruent. So I do indeed have parallel lines here. Therefore, I know that these segments are going to be proportional. So since I'm looking for GH, I'm going to call GH X. And my proportion is going to say 28 over X equals 30 over 25. And what do I want to do? I definitely want to simplify this first. 5 goes into 36, goes into 25, 5. So what I have is 6x equals 25 times 5. Let's see, that's 140. And how many times does 6 go into 140? I'm not sure. I was hoping it was going to be an integer, but it turns out it's not. So if I divide both sides by 6, x is 146, which turns out to be, if I divide both of these by 2, 7/3. So yeah, sometimes they're not going to come out to be nice integers. That's all right. Okay, now we've got a problem using the other theorem with the angle bisector. Remember saying that if we have an angle bisector, it divides this side of the triangle into two pieces that are proportional to the other two sides of the triangle. So let's see what we got here. All right, I've got the angle bisector, so I know that this and this are proportional to 12 and 8. But I don't know what these side lengths are. What I do know is that this entire side length is 18. So what I'm going to have to do is I'm going to have to call one of the parts x and the other part 18 minus x. All right, now I'm ready to set up my proportion. And my proportion says that 8 over x equals 12 over 18 minus x. Okay, so now I'm going to use one of my properties of proportions that says I can switch these two, right? I can switch my means. So I'm going to rewrite this as 8 over 12 equals x over 18 minus x. It's just going to make my work a little bit easier because I can simplify this fraction here. 4 goes into 8 2 times, goes into 12 3 times. So when I cross multiply, I get 3x equals 2 times 18 minus x. So when we come on over here and finish this problem, 3x equals 36 minus 2x. So I'm going to add 2x to both sides. I get 5x equals 36. So when I divide both sides by 5, I get x equals 36 fifths. Let's make sure that answers our question. Use the given side lengths to find QR. Well, shoot. You know what? If I had read my question properly, I would have labeled QR as x, and I would have labeled RS as 18 minus x, and then I wouldn't have to go to all this trouble of saying that QR equals 18 minus 36 fifths. And now I got to deal with this problem of fractions, and goodness knows we're not crazy about fractions, but what I got to do is I got to turn 18 into fifths. So how many fifths is 18? Well, what's 18 times 5? 18 times 5 is 90. So what I have is 90 fifths minus 36 fifths. And so finally, QR equals 54 fifths. So guys, don't make the mistake I almost made and just say, okay, 36 fifths is my answer. Read what the question is asking you for. Okay, looks like we got another problem where we have 3 parallel lines cutting 2 transversals. I'm given that they're parallel. Oh boy, got some decimals. Looks like you might get to use your calculator. So I know that HL is 2.4. Always label your drawing. KN is 2.8. MP is 4.9. And I'm trying to find the length of LN. So we'll call that X. So let's set up our proportion. 2.4 is to X as 2.8 is to 4.9. And could you have a different proportion? Could you have said 2.4 is to 2.8 as X is to 4.9? Of course you would. You'd get the same cross product, and then you'd solve for X just the same. So when we cross multiply, we got 2.8X equals 2.4 times 4.9, which is 11.76. And then we divide both sides by 2.8, and we end up with X is 4.2. And of course, don't forget, guys, if I give you units on a quiz or test, be sure to put your units. Okay, one more. Find the value of X. Alright, it looks like we're going to use our angle bisector theorem again, because we do have an angle bisector. So remember what the theorem says? It says if this ray bisects the angle, then it divides this side into parts that are proportional to the other two sides of the triangle. So let's set up our proportions. So we know that 16 is to 12 as X is to, we don't know the length of this side, but we do know the total length, and we do know this, so this side is going to be 21 minus the length of this side. So X over 21 minus X. Okay, so I'm going to simplify this fraction. 4 goes into 16, 4 goes into 12, 3. Now I'm going to cross multiply. 3x equals 4 times 21 minus x. 3x equals 84 minus 4x. Add the 4x to both sides. I get 7x is 84. And x is going to be 12. There you go. Write your summary. Good day.